All right, let's start chapter 4. We're dealing with polynomials here. We're going to take what we know about quadratics and then maybe add a few more powers and degrees to it. We're going to talk about multiplying, adding, subtracting, dividing, all sorts of different things that we could do with polynomials here. So let's take a look at 4.1. We're going to start off by graphing polynomial functions. What is a polynomial? Well, that's a monomial or a sum of monomials. So you've seen, all throughout the school year in Algebra 1 and geometry, expressions like 5x squared plus 3x plus 2. That would be a sum or a difference of monomials, all right? And all those combined together, that was 3 terms that I mentioned, that would be a polynomial. So when we go more specific to polynomial function, I have right there listed that polynomial function name based on degree. Okay, we should be familiar with the first one, the first two. A linear equation is when we have y is equal to x, okay, and it's x to the first power. Hopefully now we know number 2 for a quadratic. That's when we have like y is equal to x squared, right? So it's to the second degree. If it's cubic, then it's x to the third, and quartic would be x to the fourth. So the highest power in an equation determines what the degree of the polynomial is. So if x squared is the highest, then it's a quadratic. If you see that x to the fourth is the highest power, then it's a quartic. All right. Let's go to the next term. We have end behavior. And that is the behavior of the graph as x approaches positive or negative infinity. What I care about here is the graph at the end or in the beginning going up, or is it going down? So let's take a look down right here to the end behavior of polynomial functions. So if the degree is odd, so for example, if it's like x to the first, or x to the third, x to the fifth, what they're saying here is this: if the leading coefficient is positive, then the end behaviors, they're going in opposite directions. Okay, one is going up, the other is going down. So let's say, for example, right here, a leading coefficient, if I have like x to the first, or x to the third, x to the fifth, okay, it is going in opposite directions. As you look at the graph right here, let's start at the left side. Okay, so this is saying that as f of x leads towards negative infinity, because remember, this function is not stopping. It's going to keep going down towards negative infinity forever, as my values of x right here is going towards negative infinity as well. So the further to the left it is going, it's going to continue to go down negative infinity. On the other hand right here, as f of x, the function goes towards positive infinity, it's going up and to the right forever, infinitely, as my values of x approach infinity. So it's saying, look, when x is 100, it's still going up to the right. When x is 200, it's still going up to the right, and so on. Going the other direction, once again, if it's going to negative 100, it's going to go down to negative infinity, and it's going to continue to go down. At negative 500, it's still going to continue to go downwards. So let's go to on the right. We have the degree is odd. And this time what they're saying is if the leading coefficient is negative. So for example, if I have like negative x to the third, negative x to the fifth, etc., then remember, when we have a negative, that's going to be a reflection. It's going to flip around. So what ends up happening here, though, now is this. As the function goes towards positive infinity, it's going to go up when my values of x goes towards negative infinity this way. As the function goes towards negative infinity, because it's going downwards, when all my values of x happen to go towards infinity this way. So that right there is your odd degrees in a nutshell. So think about odd going in opposite ends for the end behaviors. Okay, up or down, up or down. And then it's going to be dependent on whether the coefficient is positive or negative. I don't know what's going on in the inside. That's why they have dotted lines there. But what I do know and can tell you is the end values just by looking at the equation, looking at the degree, and the leading coefficient. So then let's go to the next part. What happens when my degrees are even? Well, if you think about the quadratic, like x squared, y equals x squared, it's going up. Both sides are going up. Think like a touchdown. So both are going up when the degree is even and the leading coefficient is positive. So for example, we got x squared, x to the fourth, x to the sixth, x to the 100, and so on. As long as that leading coefficient is positive, it is going up. What happens in between? That's for us to figure out a different way, or using a graphing calculator. But the idea is that if the degree is even, leading coefficient is positive, your end behaviors up, touchdown. Now, if the leading coefficients are negative and the degree is even, for example, like negative x squared, negative x to the fourth, negative x to the 100, it is going, both ends are going down. And so you need to once again be able to understand the relationship and be able to write right here the end behaviors. And it's as f of x goes towards negative infinity, right, because it's going downwards, the function is going down, as my values of x goes towards positive infinity. And likewise the other direction. Okay, as f of x goes towards negative infinity, because once again, the end behavior is that it's going down, as my values of x goes towards negative infinity. It seems a little complicated at first, but it's pretty easy to grasp as you do this more and more. All right, next up, the degree of a polynomial is the highest power. So, in case you forgot, or in case you didn't hear me the first time, when I ask for what is the degree of the polynomial, that is asking, well, figure out what is the highest power in that polynomial or equation, or sorry, let's say in the expression, or it could be an equation as well. Some important things to note: no negative exponents. Okay, so if you have a negative exponent, then it is not a polynomial function. Second thing, exponents must be whole numbers for a polynomial to exist. All right, exponents must be whole numbers for a polynomial to exist. So let's put all these rules together. Let's take a look at number one. It says decide whether the function is a polynomial function. If so, write it in standard form, state its degree, type, and leading coefficient. So if I look at number one right here, I got f of x is equal to 2x squared minus 3x to the fourth plus 6x plus 1. So we got to figure out, well, what is the degree of the polynomial? It's not in order from in descending order. So that's where the kind of the trick is. I look right here, I see negative 3x to the fourth. So what does that tell me? This is a quartic function. So let's start with that. We have a quartic function. Next up, it says, if so, write it in standard form and state its degree. All right, let's say the degree right here. This to the fourth. This to the fourth power. Okay, and then the leading coefficient is the number that's in front of that, and it'll be negative 3. Let's put this now in standard form and then we'd put this in descending order. So I'll start with 3x to the fourth plus 2x squared plus 6x plus 1. All right, so there you have that right there. Let's take a look next up at number 2. Okay, we've got negative 3 over 7, x to the third, plus 7 over x minus 3. So things look a little confusing. We do have a coefficient, okay? The leading coefficient would be that negative 7 over 3. Okay, and you can have fractions for a coefficient. Okay, that's perfectly fine. However, the problem here is this. If you take a look at this negative 7 over x, if I rewrite this, this is 7 to the x, 7x to the negative first power. If we don't want negative exponents, okay? So they put it down below. Try to trick you there. So remember, one of the things I just mentioned is that there's no negative exponents for it to be a polynomial function. Therefore, this is not a polynomial function. There's number 2. All right, taking a look right here at number 3. Looks pretty tricky. We got rad 15 times x. So here's the thing. I see right here the x by itself, so that's x to the first power. I would have a problem, however, if that radical went over the x as well, because then the exponent would be to the 1/2 power. But because it's not, we got rad 15 times x. Okay, so that right there tells us that this is okay. And if it's to the first power, well, this right here happens to be a linear function. You may not see anything like that normally. Or I'm pretty sure in Algebra 1 or in geometry, you haven't seen that, but hey, that is. And this rad 5 would be your y-intercept. So we have that right there. Let's see. We want to state the degree. The degree is to the first power. The leading coefficient, that would be rad 15. And it is already in standard form, so we don't need to change that. Taking a look at number 4. Okay. Let's go ahead. I see that the highest power is this right here, and so there's my leading coefficient. So this is a quadratic. What is the degree? It is to the second power. So we'll go ahead and put 2. And then right here, leading coefficient is -2. All right, so we got all that right there. And then, let's see, let's put this in standard form. Then I have -2x squared. The next highest degree right here is 3x. And then -2 rad 3. And there you have it. Let's take a look next up at number 5. Now, it says evaluate the function. It's usually pretty easy. However, when we have like signs like negatives in front, that makes things hard. Now, the main thing that I have to tell you here is this. Your calculator is not as smart as you think. It's only as smart as its user. So the reason why I say that is because in order for you to be able to, the calculator does exactly what you tell it to do. However, it's not that smart because it doesn't know its order of operations. It'll only know the order of operations if you tell it what to do by placing if you place parentheses in the correct spots. So in order for you to figure out h of x right here, make sure when you plug things into your calculator, use parentheses. So I got negative, parentheses, 2x to the third, minus 2 times 2 squared, minus 3 times 2 plus 4. So right here, h of x, you might want to pause it for a moment so that you, before I give you the answer, but what you should end up with right here is negative 18. So big thing is make sure that you either know your order of operations or you make sure you put parentheses around things when you plug it in. All right? Okay. Let's describe the end value of the graph of the function. Okay. First thing you look for is the leading coefficient and the degree of the polynomial. So right here, I'm looking at this, negative 3x to the 6th. My degree is 6, which means it is even. Remember, if it's even, it's going to be a touchdown. However, we have ourselves a negative 3 in front, right? If the leading coefficient is negative, it's not going up, it's going down. So, what we need to realize here is this. It is doing something like this, okay? Bottom line, negative. So, let's go ahead, we'll start with, let's go ahead and say as f of x goes towards negative infinity, okay? And we could be talking about this side right here, because it is going down. Well, when is it going down? As x leads to negative infinity as well, right? So that's talking about, we're talking about this side right here on the left. Let's go to the next part. Okay, looking at the right. The function f of x is leading to negative infinity as well. But when is it doing that? As my value of x approaches positive infinity because it's going this way to the right. There you have your answer to number 7. Okay. Next up, looking at number 8. I'm looking for the degree of the polynomial, and there's several. However, but the actual degree is what the highest power, and that is to the 5th power. So remember, the degree is to the 5th, and that is odd. So it means it's going in opposite directions. One side's going up, one side's going down. So to get a general idea, it is doing this. What's happening in the middle, I don't know. Little scribbled. Since that's not my actual intent. So let's go ahead and start right here. Our function goes positive, right? It's going upwards on the right-hand side. So what I'll go ahead and say right here is this. As f of x leads to positive infinity, as x leads to positive infinity as well, right? Because we're going to the right, means it's going towards positive infinity as far as x. The function will be going up. For the right-hand side, the function is going downwards. So we're going to say it's going to lead to negative infinity as x. We're going to the left right there, which is negative infinity as well. And so there is number 8. If you put it all together right here on number 9, it says, describe the degree and the leading coefficient of the polynomial function using the graph. So we have our graph here. I'm looking at it. Okay. It's going in opposite directions. So that should tell you first off that it is odd. Remember, and going opposite ways. However, it's going to positive infinity first. All right, from the left, it's going to positive infinity. To the right, it's going to negative infinity. So what that should tell me is that my coefficient that right there is negative. look at number 8. The leading coefficient and was positive, so it was going up, right? It was going this way. But now, since we have it negative, it's like reflecting, and it's going to flip it and go like something like this right here. I think with practice, you'll be able to get that in no time if you don't already get it. All right. Graph the polynomial function. Okay. For the most part, graphing this will require you to use Desmos. Okay. Or else it's just going to take a lot of time. The problem here is this. With graphing polynomials, we don't know what happens inside. The end values we can figure out. Everything that happens on the inside is, can we figure it out? Yes. Can we figure out the exact spots? Not really, because it doesn't always turn, right? It doesn't go turn up, it doesn't go up or down, meaning my turns, at whole numbers. So in order for you to get that, it's not really possible to do by hand. So I would say graphing this would require a graphing calculator. The end values, no. Okay, but the actual graphing would require a grapher. So when you look at this in 4.1, you can use Desmos or you can use a graphing calculator. However, once again, when it comes to a test, I'm probably not going to ask you to actually graph, but you need to know what the end value should look like. So let's go to number 12. Okay, they give us this scenario. It says sketch the graph of the polynomial if the function is increasing when x is -1 or less than -1, and between 0 and 1, well, when x is less than 1 and x is greater than 0, it's also increasing. So I'm looking at I put a grid down, I have my axis, and it says that the function is increasing when x is less than -1. So that should tell me right here, well, here's -1, right? So I'm going to go ahead and put that down. My function, it says it's supposed to go up. Now, how high up, I don't know yet because it didn't tell me. There's more information that they show you, though. Now, it says f is, let me go ahead right here. It also says that it's increasing between 0 and 1. So let me go ahead and put right here between 0 and 1. I'm going to put dots right there. At some point, it is increasing as well. Okay, so let's just put something like this. It's increasing. It says f is decreasing when x is less than 0. Okay, so when x is less than 0, -1. So that's going to be in between this part right here. And it's decreasing. So let's go ahead, and I will go ahead and show something that's going to go downwards right here. And then when x is greater than 1, it's also decreasing. So right here, this is where 1 is. We're going to go ahead and show that it is decreasing down. Now, why don't I go all the way up? Okay. Well, let's take a look at the last thing. And f of x is less than 0. Okay, for all real numbers. So that right there is telling me that, look, the function is less than 0 for all real numbers. So it cannot actually go all the way up, okay, past that y-axis. Because remember, f of x is y, right? Remember, f of x represents y. So let me go ahead and finish this off right here. It's increasing, going all the way up right there. It's also increasing and going all the way up right here. I could have it go up a little bit higher, but it has to be below the x-axis right there for my values of y. And there you have it. There's my function. Describe the degree. Well, the end values are both going downwards, so that should tell me it's even. What's the leading coefficient? Well, since it's both going downwards, then it is negative. And there you have it. Section 4.1. Now you can go ahead and graph and know the difference between even and odd functions.